Okay, so let's take a look at the graph of this first of all. So if I put, how would I put secant squared in? Yep. And sine x. And I have to make sure I'm in radian mode because we always switch. And my window, I'm going to do 0, well, I'll do negative pi to 2 pi, scale of pi halves. We might have to change that a little bit. Yeah, I'm going to zoom that in. Okay, so the area that I'm specifically looking at is between secant squared and sine from 0 to pi fourths. So let's change that window. Let's do 0 to pi fourths and see exactly what we're looking at. And I'm going to do this. Okay. So I have a part of the secant graph and a part of the sine curve. And if this was 0 and this was pi fourths, I'm looking at that region right there, okay? So can you guys tell me an expression to integrate then? Which one's higher? Secant squared. So I'm integrating from 0 to pi fourths. This should be really f of x and g of x. So it's secant squared minus sine x. I'm going to just put it all together. Okay, so let's integrate that then. The antiderivative of secant squared is tangent, and then minus the antiderivative of sine is negative cosine, right? Which would change this to a plus cosine then. Are you following that? Okay. And then we're doing pi fourths to 0. Alright, now I do, Noah, have to be careful about the zeros in this case because when you're evaluating trig functions at 0, they're not always 0. So let's put it in. Tangent of pi fourths plus cosine of pi fourths. Okay, yeah, I can skip that step. Tangent of pi fourths is 1, right? What's the cosine at pi fourths? Look at you guys. Look at Andy. Alright, what's the tangent at 0? 0. What's the cosine at 0? Okay. What do you notice? So this is 1 plus root 2 over 2 minus 1. So the 1's cancel. We'd be looking at root 2 over 2. Okay? Any questions on that?